Hello guys, I am Nidhi Bagalwadi Sankal Learning Solutions, your science teacher. So in the last class, we discussed regarding the reflection of a light or the image formation through the convex mirror. Now we are going to discuss how the image will be formed by the concave mirror. So in the concave mirror, we are going to study in detail where the object is placed and where the image will be formed. Okay. So to know in detail regarding the image formation, please do watch the full video. Right. So here, as we all know that we learned in the last videos, in the previous videos, we discussed many cases that, for example, when the light rays will be passed parallelly to the principal axis, when the light rays will be passed by passing via the center of curvature, when the light rays are passed via the focus of a principal focus of a point, right? So these all we discussed. So those cases only we are going to adapt in the concave as well as convex mirror. So let me consider an object is placed at an infinite distance. Infinite distance. What do you mean by infinite distance? Infinite distance means according to this concept. Infinite distance according to this. So at a far distance. At a far distance when the object is placed and a parallel beam of light when it is focused on a concave mirror. Okay, so this is a parallel beam of light which is incident on a concave mirror and it's parallel to the principal axis. So the reflected ray of that light will be passing through the principal focus. Will be passing through the principal focus. This is when an object is placed at the infinite distance from the mirror. And the image formed at the principal focus will be very small, so we can call it as point image. Okay, so this is the case when the image object is kept at an infinite distance from a concave mirror. So let us take an image now. 1 minute. Yeah. Let us take an image, or let us consider a concave mirror, and let us label the pole P, okay, and the center of curvature C. Okay, now let us take an image near to the center of curvature. Near to the center of curvature, that is at a far distance greater than the radius of curvature. The distance from CP, that is, it gives the radius of curvature. So let us take an object which is named as OG beyond, that is after the center of curvature, right? Now let us consider two rays of light. One ray we will consider at which is traveling parallel or which is passing parallel and incident on a spherical mirror. Fine. Incident on a spherical mirror and parallel to the principal focus. Okay, so this is the direction. And the reflected ray will be formed here. So this is a reflected ray. Where it is formed? No doubt it will be formed at a principal focus. It passes through a principal focus. Now let us consider one more ray of light. So this ray of light from the top of the object is passing through the principal focus of a mirror. It is passing this incident ray of light passing through the principal focus of a mirror, and we know that the reflected ray, whatever will be there, it will come parallel. The reflected ray will be parallel to the principal axis. Whenever an incident ray passes through the principal focus, the reflected ray will be parallel to the principal axis. That we learnt in the last video. So these are the two divergent rays. So let me differentiate it. So these are the two reflected rays. One is reflected via the focus, one is reflected parallel to the principal axis. So let me just extend it so that we will get to know clearly. Okay, so here at this point where two reflected rays met. Where two reflected rays met, at this point the image will be formed. At this point the image will be formed. So it is what? It is greater than the focal length. The image is formed at the distance which is greater than the focal length, lesser than the radius of curvature. Okay, this is the image. Okay, and let us name it as IJ. IJ. See here, by seeing the size of the image will be smaller, that is diminished, highly diminished, smaller in size. Next, this image is not erect, it is upside down, it is inverted. The nature of image is inverted. That is, see here, O is a top of the object, but here J is a top of a object, not I. So it is an inverted image, it is diminished image, and it will be real image. What is real image? So when you place a screen in this point, at this point you can get the image on the screen. So that is the meaning of real image. So here the nature of image will be, in the concave mirror, the nature of image will be, the first one is real, it is obtained on a screen. The next one is, it is inverted. The third one is, it is diminished. So this is when an object is placed at a far distance, that is beyond the radius of curvature. This is where an image will be formed. Okay. This is the case, and this will be the nature of image. Now, let us consider a case. So here, this will be center of curvature. This is pole. Okay. And this is the principal axis, and Mn will be the aperture or diameter of a spherical mirror. Now, let us keep a object on the center of curvature. Let us keep an object on a center of curvature. Right? When we keep an object on a center of curvature, OJ, right? Then we will focus, or we will we make the incident parallel beam of light incident on a spherical mirror which is parallel to the principal axis. So at that time, the reflected ray will come in this direction, that is at the principal focus. Principal focus. Okay. And this will be a reflected ray. Let me color it with different chalk. This will be a next. We will take another ray of light which is passing through the principal focus, and the reflected ray will be parallel. It will be parallel. Okay, it will be parallel to the principal axis. Okay, it will be parallel to the principal axis. So let me draw it clearly. Like this, and this will be formed at this point. Okay, at this point the image will be formed. So as I don't have a scale, the lines is not proper here. So here what happens, the image will be formed exactly at the center of curvature. The image will be formed, that is IJ. This is OG. The image will be formed exactly at the center of curvature, and the nature of image will be same, that is real, inverted and diminished. And the size of an object and the size of an image will be same. So when a ray of light or when an object is placed at the center of curvature, so the image will be formed at the center of curvature only. So here I can say the distance between the object and the pole, that is pole of a spherical mirror. Pole of a spherical mirror, it is denoted by U. It is called object distance. The object distance and the distance between the pole and the image, which is denoted by small v. Image distance, object distance and image distance will be same, and the size of object and image will be same when an object is placed on the center of curvature. So this is how it works when the light is reflected by the concave mirror. So in the upcoming session, we will study one more case when an object is placed between, that is before the radius of curvature, after the focal length. Okay, in the next session we are going to study that. Until that, learn science, observe science. Have a nice day.